The brain, 100 and some odd years ago, a winner of the Nobel Prize with Golgi, was Santiago Ramon y Cajal. He said 100 years ago, he's the father of neuroscience. The father of neuroscience. He wanted desperately to believe that the brain could change as a result of our experience. And he said, in the adult brain, nervous pathways are fixed and immutable. Everything may die, nothing may be regenerated. This was the state of our science 100 years ago. 60 years ago, it was the state of our science when The Fool on the Hill came out. A lot of researchers who tried to suggest otherwise in the 70s and 80s fell out of good reputation in the community, and now it's accepted to be absolutely the case. Our brain changes. Neuroplasticity is the change of the structure and function of our brain. We'll talk about what those two things mean in response to our experiences and, from a mindfulness perspective, how we choose to experience. So there was some research that was done by a neuroscientist at Harvard where he looked at taking people who were subjects in a study who had never played the piano before, and he had them play a 5-finger scale over and over and over again, 2 hours a day to a metronome for a week. And before they started, and each day while they were doing it, he used a device called a transcranial magnetic stimulation to, through a coil, put a magnetic impulse into the brain that would disable the neurons in the motor cortex. This is what you use to, it's active when you engage in a motor skill, to identify how much neural real estate was involved in the playing of this, how much of these motor cells were associated with the playing of this finger scale. And each day, as they were doing it, and at the end of the week, guess what he found with regards to the amount of neurons that were used for playing this 5-finger scale? None. What else? It increased. It increased. Now, 40 years ago, this would have been stunning. Today, this is really interesting. It shows that other neurons around those neurons were recruited. The brain said, oh, this is an important, he's playing the piano, she's playing the piano. This is, okay, if this is something we're going to be doing, let's, guys, I need help. And the area starts to grow. If you look at, there was a wonderful study that was done looking at the left hand of violinists compared to non-violinists. And the neurons in the motor cortex associated with the left hand were immensely rich and robust. And the longer they'd been playing, the richer and more robust this collection, this part of the brain was, compared to those who hadn't been. And on the right hand, they were the same. The right hand is not doing the same kind of... Now, here we're, though, watching the brain changing in real time. Now, he also had a group that did what you all did. They just imagined it. For 5 days, for 2 hours a day, they imagined playing the piano, the same scale. And guess what he found? The same thing. He found the same change in the neural real estate of the brain. In Neuroscience, we call this gerrymandering. The intentional. And it's intentional, right? It's intentional. You were choosing to do that. You were choosing to engage in your experience that way. The intention is very important. If your hand was just doing it while you were thinking about something else, so that the hand and the motor is happening, you wouldn't have nearly as robust a change as if you are paying attention to what you're doing as you're doing it. And they found, in fact, that when they looked at how well these people performed who had been doing it for 5 days, they had a computer that assessed how proficient they were at this scale, and they looked at people who just imagined it doing it for 5 days, they were 3 days as effective as the people who had been doing it for 5 days in real life. That is, they had actually developed the skills, never having actually done it physically in the sense of using their hands that you can see. And with 2 hours practice, they were caught up. And they find that the fingers like 25% increase of certain muscle growth when you're actually doing it, and like 18% when you're just thinking about doing it. Because when you're doing it, the motor neurons that are actually engaged when you're doing it, we have to really change our terminology here. Doing it is now, just thinking about doing it is not that different than doing it. You're just not seeing it in the way you're used to seeing it. But it's all really happening up here. And so much of what we do when we're in court, when we're in lots of environments, is playing it out in advance. And that's actually doing it.